In this video, we're going to review different ways to find equivalent fractions. And there's 3 different ways we're going to look at. One is drawing a picture. Another one is using a number line. And the last one is using the rules that we know about equivalent fractions to help us make them using multiplication and division. So for this first one, I'm going to show you drawing a picture to review. So we have 3/4 here, and we have 6/8. And I'm going to draw a picture of both of them to help me compare the two. So 3/4, that means I need to split this into 4 equal pieces. And 3/4 would look like this. 3 equal pieces shaded in. Then, let's see, 6/8, I'm going to make these pieces the same, so they're 4, and then I'm going to split all of those in half. Now I need to shade in 6, 1, 2, 3, 4, 6, and you can see they are equivalent. They ended at the same place here on their picture, so these would be equivalent fractions. Now the next one we can use is a number line, and a number line goes from 0 to 1 when we're working with fractions because 1 is the whole. So this represents the whole amount we have. What I like to do is whenever I have a number line, I like to make it a thick number line, and it helps me see the picture as I'm making my number line. So let's start off here with a third first before we split into ninths, because I can do thirds easier if I do them first. So I'm going to go and split this into thirds the best that I can. I'm going to try that again. Third, third. And I like the thick number line because sometimes if I'm not sure where I put my label, I can draw this quick picture so I can see, oh, okay, so 1/3 is actually going to go right here. 1/3. Now 4/9, I'm going to split each of these into 3 equal parts, so I'll have 9 total. And 4/9 would end up 1, 2, 3, 4, just a little bit to the right. See, 4/9 is a little bit bigger than 1/3, so these are not equivalent. And then if I want to take off the thick number line, I can just see it just as a number line without that other piece on it. Now the next thing I can do is I can use multiplication to help me. When we're working with equivalent fractions, in order for a fraction to be equivalent to another, you have to be able to multiply the numerator and denominator by the same amount. So I'm going to ask myself, is there anything times 5 that would get me 20? And there is, 4. Is there anything times 9 that would give me 45? There is, 5. Now these 5/9 and 20/45 are not equivalent because on this one we didn't multiply by the same amount. They can only be equivalent if we're multiplying by the same amount to make them equal. So let's look at this one. 6/7 and 18/21. I'm looking to see if there's anything I can multiply the numerator by to make it equal to this numerator. And I could, times 3. And 7 times 3 equals 21 too. So these fractions are equal because I was able to multiply by the same amount for the numerator and denominator. Now I'm going to use this to kind of help me create some equivalent fractions for 9/10. So up here I'm going to keep track of all my equivalent fractions, and down here I'm going to show my work. So 9/10, I'm going to start off by multiplying it times 2. And when I do that, 9 times 2 is 18, and 10 times 2 is 20. So 18/20 is equal to 9/10. Now I can multiply by 3. And if I did that, I would get 27/30. The great thing about equivalent fractions is really you can multiply by anything you want to multiply by. So I could do 9 times 10, or 9/10, let's do times 5. 9 times 5 is 45, and 10 times 5 is 50. And you can do that with any amount as long as you're multiplying it. You could even do it by a very large amount if you wanted to. You could multiply both of them by 100. And if you did, that would give you 900, scoops out of the way, over 1,000. Now, the other thing that you can do is you can actually divide to make equivalent fractions. Sometimes when we have fractions that have large numbers in the numerator and denominator, we can actually divide to make them into smaller numbers but still have equal fractions. So if I look at 50 100ths, I'm going to say, is there anything I could divide by the same amount for both of them that I could get an answer with? And I see one. I could do 10. 50 divided by 10 is 5, and 100 divided by 10 is 10. Now I could also divide both of these by 50. 50 divided by 50 is 1. 100 divided by 50 is 2. Now, of course, I can also multiply 50 over 100 by amount to make 1 2. So let's multiply both of them by 2. 50 times 2 is 100, and 100 times 2 is 200. So remember, whenever you're comparing fractions, you can draw pictures, you can make a number line, you can multiply the numerator and denominator by the same amount, or you can divide the numerator and denominator by the same amount.